Hey guys, alright, one more video. Hopefully I can do this in less than 10 minutes. So you're going to have this worksheet due tomorrow and this one due tomorrow as well. Maybe I'll make one of them due Thursday. I'm not trying to give you like a ton of stuff, but I don't know, just trying to figure this out, kind of like everybody, like how much to do and whatnot. So anyways, you're going to be doing these based on what we do right now. Okay. All right. Here we go. So table G, talked a little bit about it yesterday, has those solubility curves on it, and if you hopefully you have reference tables and you can kind of look at these things, but on your own, obviously. But if you look at these, most of these lines increase. So if you take KClO3 here. Remember, solubility, yesterday I said, is the amount of solute, so the solid stuff, liquid or gas, but typically solid, getting dissolved in water. How much of that can you dissolve in a certain amount of water? Now, 100 grams of water, 100 milliliters, it's just a little bit of water. But so this is how much water, so imagine you have a beaker with this much water in it. All of these substances are added to their own beaker with that much water. These lines tell you how much you can dissolve. If you add any more, it won't dissolve. It'll just sink to the bottom. You stir it all you want, it won't dissolve. The temperature plays a huge role. If you heat it up, notice how most of these, like take KClO3, if you heat it up, you can add way more to the exact same amount of water. So if you have 100 milliliters of water, you can dissolve 60 grams if the water is basically boiling, 100 degrees. Well, if you drop the temperature down to 0, basically freezing, you can only dissolve maybe 5 grams. So adding heat allows the water to do a better, more efficient job of breaking down the solute, because water is a solvent, and that's really what this is all about. These three, HCl, NH3, and SO2, those are gases. So gases want to be cold, meaning when they're cold, they clump together like penguins, right? Talked about it. So lower temperature for gases, the higher the solubility, meaning I can dissolve more. So sulfur dioxide gas, if water's 90 degrees, you can what? Maybe dissolve 3 grams. But if the water is 10 degrees, you can dissolve 16 grams. That's because gases want it colder. So anyways, there's 3 things I want to teach. Unsaturated, saturated, supersaturated solutions, and using table G. So I'm going to go to the whiteboard thing here, give you the definitions here, and then we'll go back and we'll use table G, and I'll talk a little bit about this worksheet here. All right, so, okay, here we go. Unsaturated solution. Unsaturated solution. And what is that? It's when you have less than the max amount of solute dissolved in a solution. Meaning, if you go to table G and you say, all right, this certain solute can dissolve, let me rephrase that. This certain solute, so you pick one, NaCl, KNO3, whatever, you pick one, and you look at the temperature and you say, okay, I can dissolve 20 grams, but I only put in 10. So if it can dissolve 20, but I only put in 10, that's less than the max. That's called an unsaturated solution. And the key here, and especially on the regents in table G, is this is under the line on table G. So let me explain that. So let's take KClO3, for example. So if we take KClO3 and I have 100 milliliters of water, 100 grams of water, and that water is at 70 degrees Celsius. If I take, I don't know, 30 grams of KClO3 and I dissolve it in that 100 milliliters of water, and that water is at 70 degrees. So the water is at 70 degrees, 100 milliliters of water. It's a little tiny bit of water. Put a thermometer in. Tells me it's 70 degrees. I add 30 grams of KClO3. I stir it up. It will all dissolve. How do I know that? Because it is underneath this line. This is the KClO3 line. Anything under it, so from here, I wish I could annotate this, but from here all the way down to 0, if you add any of those numbers, right? So if you add 0 up to, whatever we think that would be, 36, 37 grams, anything less than that, it's called unsaturated. So 30 grams of KClO3 at 70 degrees Celsius would put me right there. Right there is underneath that line. Therefore, it's unsaturated solution. So I'm gonna put that in the notes there. Where am I? So for an example here, if we have 100 milliliters of H2O at 70 degrees Celsius and we add 30 grams of KClO3, that puts us under the line that is unsaturated. This worksheet here is exactly this. You're just going to tell me, is it saturated, unsaturated, supersaturated? Okay. All right. Saturated solution. What am I doing for time here? All right. Saturated solution. This contains the max amount of solute. I'll keep it brief. The max amount of solute. That means if you add any more, it will not, If you add any more, it will precipitate. So I'm just going to kind of put that. Adding any more solute causes PPT, meaning the solid will, you know what, it causes precipitate, but another way to say that, so it causes precipitation, which is a solid, or we can just basically say adding any more solute will not dissolve. So you can stir it up all you want, it'll never dissolve. And the way we teach this is on the line. So if we go back to that KClO3 example, 70 degrees Celsius, 100 grams of water, right? 100 milliliters of water. The 100 grams of water, 100 milliliters of water, the Regents will give you that number because that means you can use this table. If it's less or more than 100, that changes things. And the homework, the worksheet talks a little bit about, well, what if you have 200 grams or 50 grams? Well, if the water is 200 grams and you double the water, then you're going to double all these masses here. If you cut the water in half, then you would cut the masses in half. We'll address that when I go over it. All right. Anyways, 70 degrees, KClO3, we already talked about 36, 37. So 36, we'll say 36. 36 grams puts us right on that line. So if I want to make what's called a saturated solution of KClO3, and I know I have 100 milliliters of water, and I know the water is 70 degrees, I need to add 36 grams of KClO3. 36 grams is exactly on that line. I cannot add any more. If I add any more, I'll be above the line and it won't dissolve. If I add any less, that's called unsaturated. It will all dissolve and I can still add more. So 37 grams. So the example, in 100 mils of H2O at 70 degrees Celsius, 37, not 30, we said 36, didn't we? 36 grams of KClO3. That is on the line, that is saturated. Okay, last one, super saturated. And to kind of go faster, that's where you add too much and you go above the line. So super saturated solution, adding more than the max amount of solute and we say above the line. And the example would be 100 milliliters of H2O at 70 degrees Celsius. Let's say we add 40 grams of KClO3. All right, I know I'm going quick, but again, you can pause and do whatever you need to do there. All right, so now I'm at 70 degrees. Same thing, KClO3. If I add 40 grams, now I'm here. I'm above that KClO3 line. If I'm above it, that means it's supersaturated. So these 4 grams, right? So 36 grams will be dissolved. So you stir that up, you put the 40 grams in, you stir it up. 36 grams will dissolve because that's the max. The extra 4 grams will just precipitate and settle to the bottom. So on here, above the line is called supersaturated. So adding more than the max amount of solute, and then parentheses here, solute above max will not dissolve. All right, so again, I'm going to stop this. Use these numbers and table G to figure out, is it unsaturated, supersaturated, saturated. That's what you're doing. Okay.